Euclid's Elements, Book 1, Prop 34. In parallelogrammic areas, the opposite sides and angles are equal to one another, and the diameter bisects the parallelogram. So we're given a parallelogrammic area, what we would call a parallelogram. This is a figure formed by two sets of parallel sides. So side AB is parallel to side CD. So let's start with our givens here. AB and CD are parallel. And AC and BD are parallel. So let's draw it like this. And from this, we're going to prove that the opposite sides, so these sides, we're going to prove a whole bunch of things. We're going to prove that AB is equal to CD, that AC is equal to BD, that the angle at A is equal to the angle at D, and that the angle at C is equal to the angle at B. And finally, if we have a diameter, that the diameter will bisect the parallelogram into two equal halves. So those are the 5 things we're going to prove. So let's take away what we haven't proven yet. We're going to still prove these things. And we begin by this proof by noting that we have two parallel lines, AB and CD, and we have a line falling on those lines, or what we call a transversal. And a transversal makes alternate angles equal. So let's label these angles maybe a little differently here so we can see them. Angle 1, angle 2, angle 3, 4, 5, and 6. So let's do a little chart here. So we can use Prop 29 to let us know that when we have a transversal falling on parallel lines, it makes the alternate angles equal. So angle 1 is equal to angle 4. Now, if we consider this other set of parallel lines, these two lines, we also have a line falling on parallel lines, and it makes these alternate angles equal, namely angle 2 equal to angle 5. Also, again, through Prop 29. Now, we also have this line in common. This is common to both of these triangles. So now let's look at each of these triangles. Let's look at this triangle and this triangle. And what we see is we have an angle equal to an angle, a side in between, and an angle equal to an angle. And this should remind us of angle, side, angle equal to angle, side, angle. This is Prop 26, our angle, side, angle proof for equality. And when we have this situation, we know that the opposite sides are equal. So AB equals CD. Okay, that's this. And AC equals BD. That proves this. And the remaining angle, angle 6, equals the remaining angle, angle 3. And that's the angle at A equaling the angle at D. Now we just have to show that the angle at C and B are equal. Well, that's easy. We know 5 is equal to 2, and 4 is equal to 1. Therefore, the whole here, 5 plus 4, is equal to the whole here, 2 plus 1. And that's just a use of common notion 2. When we have equal things and we add equals, then the remainder is equal. So this whole angle made up of these two things, which are equal to these two things, equals this whole angle. Therefore, the angle at C equals the angle at B. The last thing we're going to show is that the diameter bisects. And now we can take any sets of sides and angles. It might be convenient just to take this one here. So we have side 1, angle here, side 2. And that's equal to side 1, angle, side 2. And this is our side angle side. So this is Prop 4, side angle side, proof for the equality of triangles. And since we have the situation, these two triangles are equal. And that means triangle ACB is equal to triangle DCB. If these triangles are equal, then we have bisected this parallelogram into two equal triangles, and therefore the diameter bisects. Therefore, in parallelogrammic areas, the opposite sides and opposite angles are equal, and the diameter bisects the parallelogram. That's what we're supposed to prove, so we conclude QED.